If you want to be extra like me, you can also use purple and orange. I'm going to for sure use these three, the three big key ones. Alright, so remember when we have a quadratic, okay, when we have a quadratic expression, that's our special trinomial. So special three parts. We talked about it a little bit on that last problem. Does anyone remember what is a quadratic expression?
A, B, C.
What? There's an A, a B, and a C. What goes with the A? The x squared. What goes with the B? X. And then what goes with the C? Nothing. It's just a constant. Good. Now, we talked last week about that word quadratic.
What is that?
What is that prefix of quadratic? A quad, right? When we think of quad, what number does quadratic or quad usually tell us? 4. But how many is this? 3. Remember we talked about that? It was kind of weird that a quadratic normally means 4, but this is a trinomial. It's only 3. Okay? So when we have those 3 parts, what's going to happen here is the reason we call it a quadratic, and actually not the full reason, but what I like to pretend is the reason, is that when we do an area model, how many parts are in our area model? 4. So we need to take this trinomial and we need to split it up into 4 parts for that quadratic. Okay? 2 of the parts are really easy to see. Okay? One part that's really easy to see. Okay, you can just grab one. You don't need the whole pack. Okay, the first part that's really easy is this ax squared. I don't know where he is. You? Oh, cool. Alright, this ax squared goes in this first box. Ax squared. That first term goes in that first box. Alright, our C, again, is another one that's a little bit easier. Our constant. Our constant's going to go in this last box. However, this bx has to be split. And that's the part that's split between the two. Because whenever we did that, remember that like terms would always be the something x, something x. When we split it, though, something we really need to remember is that both of these are going to have an x. We have x and an x. But we have to figure out what number goes in each of those boxes in order to make this whole quadratic work. Okay? In order to do that, there's a couple things we're going to do. The first thing we're going to do is we're going to take our A times our C. Okay, whatever this answer is, we're going to use that to do something similar to what we did last week. We did this on Friday. We did where we multiplied 2 numbers to equal that answer. That's the same thing there. If you want to draw a little arrow, it'd be like, what the heck? But then we also wrote what other type of equation? We did a multiplying equation, and then we also did a adding equation, yeah. And we wanted to add up to that middle term, that b, because that's the part that when we combine like terms, it'll equal b. I'm going to do b in orange here. Okay, whatever those two numbers are, that's where we get these numbers from. So 1, 2.
What is that 8?
What are you asking, Dolan?
What is that 8?
8?
Yeah, the 8.
This? This. Oh, those were just the answers. I was just trying to circle what your answer would be.
Oh, I thought it was the 8.
Yep, I can see where you thought that. So whatever those numbers end up being, those are the numbers we'll use in these other two boxes. Alright, we're going to try a couple examples today, and then tomorrow we'll give you a lot of time to practice and puzzle this out together. Okay? So here's our first example, example number 1. So we have 7x squared minus 18x minus 9. So first thing I want to identify is my A, B, and C. So what is my A? Good, and remember when we think of just A, we want just the coefficient. So which one is just the coefficient? That's the constant. I'm sorry. In the 7x squared, that was right to say 7x squared. When I ask for A, I want just the coefficient of that term. So just the 7 is A. All right, what is my B? Not just 18. Negative 18. Good. So my B is at negative 18. And what is my C? Negative 9. Alright, the way I like to set up my problems for some reason, I always like to put the box on the right side so I can have a little bit more room to work with that. That's not for a while. Oh, just kidding. That is just, yeah, that's next unit. Not that I needed to tell you that right then, but I did. So over here I'm going to make my area model with my 4 boxes. Based on this problem, there are 2 boxes I can fill in right away that I don't even have to think about. Which boxes can I fill in right away? Yep, the A box, 7x squared. And the C. Where does C go? In that bottom right one, so negative 9. Alright, so now what we have to do is we have to figure out what 2 numbers we can put here that when I combine them, it's going to make negative 18. But not only when I combine them does that make negative 18, but I have to be able to factor this out in a way where I can find those outside numbers. So in order to do that, we follow this pattern, the A times C, and then based on that, we'll write a multiplying equation and an adding equation. My A times my C. What is my A? 7 times, what is my C? Negative 9. If you want to color code those, go for it. 7 times negative 9. So we did our A times our C. Yep, you got it. If you need a calculator, that's okay. 7 times negative 9. Negative 63, good. So now another multiplication problem.
Oh,
And when I write that multiplication problem, I'm going to write the same answer, negative 63. But now I'm also going to write an adding problem. What do I want it to add up to? Yeah, our B, our negative 18.
why do we need negative 18?
Because when I combine these two, I want them to make that B term. So when I take whatever this is and this is, when I add them together, they have to make that middle term. Alright, so for those of you that were here last week Friday, you might remember this part. If you weren't here Friday, this is really what we did. It's a big puzzle. We went to our blue sheet. On our blue sheet, which part did we look at? The 63 or the 18? Good, it's a multiplying, and this is a multiplying sheet, so we look at 63. And we want to look at those pairs. So we looked at 1 and 63. I know when I multiply 1 and 63, that'd give me 63. When I add them, does 1 plus 63 make 18? Nope. So I'm looking at those pairs. Does 3 plus 21 make 18? That'd be 24. What about 7 plus 9? Is that 18? If you're not sure, use a calculator. 7 plus 9? That's 16. That doesn't mean we're looking for 18 as our magic number. So none of them worked for adding. Does anyone remember what's the other thing we can do? What operation? Subtraction. And if I'm subtracting and I answer, should I do my small number minus a big number or big number minus small? What's going to give me a negative?
Big number minus small.
Small minus big. So I'm going to think 1 minus 63. Does that equal, oops, that was 3. 63. Does that equal negative 18? Nope. 3 minus 21? Yeah, that one works. 3 minus 21. So when I write my answer, I do a positive 3. And it's 3 times what? Negative 21. Because in order to make that negative 18, I wanted that negative 21. Alright, so we're going to take that 3 and that negative 21. If you want to color code this, this gets a little extra here with the color coding, but it's up to you. I'm going to put the 3 here. And I'm going to throw this negative 21 in the other box. Now you could have flipped those around if you wanted to. We're going to get the same answer. Big thing to remember with that 3 and negative 21, is that supposed to be our constant in this quadratic? What are the 3 and negative 21 supposed to be? Is that supposed to be the A, the B, or the C?
The B.
The B. And what variable does the B have? So this has to be a 3x and a negative 21x. Because now together they make an negative 18x. Alright, so now we have our box. Now we're back to just our warm-up, what we worked on before. We can pick any row or column to start with. It doesn't matter which one. So do you guys want to do 7 and 3, 21 and 9, 7 and 21, or 3 and 9? 7 and 21? Okay, so if I look at my blue sheet, I want a common factor of 7 and 21. So what's the biggest number that's both in this box with 7 and this box with 21? 7. So 7 and 21, that goes side to side. So I'm going to put 7 out front. And do they both have an x?
Yeah.
Yep, so we can take out a 7x. Now that we have one of the outside numbers, we can think about the rest as multiplication. Or we can keep doing greatest common factor. I like to do multiplication. So I'm going to think 7 times what would give me 7? 1. 7 times 1 is 7. Do I need another x there?
Yeah.
Yep, because I need an x squared. X. Alright, times what is negative 21? Yeah, if you're not sure, take a look back at this. 7 times what was 21? 3. But that would be a positive 21. How do I get a negative? Negative 3. Do I need another x there? Nope, just the negative 3. Alright, and then on the bottom, 1 times what is 3? 3. And we can double check in that last box, my box with the negative 9. Does 3 times negative 3, does that make negative 9? Yep. That should be your double check to see if you did it right. If that didn't work, then we knew something went wrong. Alright, so our last step here is to write out our binomials. What are the parts that we will end up multiplying to get that those inside amounts? Which parts get grouped together?
7x.
Good, 7x gets grouped together with 3, the positive 3 on the bottom, so these are. What else is going to go together? 1x and negative 3. When I write 1x, do I need that 1? No. What could I just write? X. And we could write x plus negative 3, or we can write it as x minus 3. Either way is all good. So there's actually quite a few ways to write this. We could have also flip-flopped it. We could have done x plus negative 3 first, and then 7x plus 3. And that's our answer. Alright, we can double check this, which is really great. If I did 7x plus 3 times x plus negative 3, I would write it out in my box. We can just double check all that multiplying. Does 1 times 7 make 7? 7 times negative 3 makes negative 21. 1 times 3 is 3. Negative 3 times 3 is negative 9. Okay, and then if I wrote this all out, which parts would I have to combine? Yeah, I'd have to combine these two that are diagonal. And is negative 21 plus 3, does that give me negative 18? Yeah. So it's just what we did before, but we're working our way backwards. Alright, tomorrow our plan, we have 5 more minutes, so chill, relax, breathe. Everyone take a breath. Tomorrow we are going to be doing one more problem together to get a review of this. And then you are going to be working together as groups. Some of us really struggled to pay attention today. Some of us are still struggling to pay attention. Hi. Thanks for joining us. So, if you're somebody who really struggled, you are going to want to watch this video because this is kind of a lot of steps. It takes a while, and that's why